It is 7 o'clock. Wow, this room really filled up. This is awesome. Can you guys hear me? All right, get had some thumbs up back there. Excellent. Well, welcome to CAPCA's program that we weren't quite sure was going to happen. We haven't met in over 2 months, so it's really nice that the snow did not keep us away tonight. I'm the president, Cheryl Duval, and I'm so excited to see so many people here. And we have a bunch online, I believe, as well. So, pretty excited about that. Before we get to our wonderful speaker and this subject that I am very deeply interested in, the Key Bridge build, we did want to review a couple of announcements with you from CAPCA's side, and I'm going to try to make sure this works. Okay, there we go. All right. So we'll start the speaker presentation around 7:10, and then I think, Jason, about 45 minutes or so, and then Q&A. I know we have a bunch of people were telling me in the bar a couple of questions that they had for you. So I know we've got some questions already coming. And then we'll take questions from the attendees at that time, and then we'll draw the door prize after that. So we do the 50-50 before the program and the door prize after the program. All right. We have a new board of directors. Some people are new, some have been around for a while. So you can see them listed there. I would like anybody from the board to please stand up. So Rob is standing, Will, Bob out there. Who else from the board? Anybody else out there? Chuck? Chuck is actually a boat show chairperson, and Dave Sire. Okay, thank you very much. And I do want to point this out because it does take a lot of work to provide all the programs and the services that we do. And that leads us to the next slide. We need more volunteers. So on your tables in that very, very bright chartreuse or whatever color you might call it, hold that up, Jason. That would be great. All right. On that form, it gives you some options that you might be interested in. I would like to thank the volunteers that are listed here because we've had some people where we said we need volunteers and they actually did reach out, raise their hand, or send us an email or answer the phone call. How many of you answer a phone call from a stranger that you don't know if the number shows up? Very few, right? Okay, just a couple. Jim Kennedy, please stand up. Jim answered a call from me one afternoon and he was in the process of moving and he even answered the phone and he has now joined our budget and finance committee. So thank you very much, Jim. Is Mike Martell here? Mike volunteered to be our Meet the Captain editor, which is a great job because I just stopped doing it and I loved doing it and I didn't want to give it up, but it's a little bit much to do with everything else. So Mike Martell spoke up and said that he would be happy to be the Meet the Captain editor. We also have Adam Yearwood, who not only is he our assistant treasurer, but he stepped up and said he would be interested in writing quarterly articles for Prop Talk or Spin Sheet. And he has started doing that for us. So he's representing CAPCA when he does that. So we're very happy about that. He is not here tonight. We also have Vicky Saporta, Aaron Manor, Alex Wolf, Zal, Hillary Howes, and Lynn McClaskey have all agreed to speak at the Sailboat Show or the Powerboat Show this spring. So thank you very much for that. And Rob and Chuck Thompson, our wonderful Chuck, stand up. Our boat show chairs, please stand up. Yes. And they have some handouts on your tables as well. Chuck, just stand up. Thank you. And Rob. Okay. Yeah. Those are the people to see if you want to volunteer. And there's also QR codes to make it very, very easy for you to sign up on Sign Up Genius. You'll see that we need more volunteers. They're on your screen. They're also on that very brightly colored paper. And one that I want to point out is mentoring coordinator. We have a mentoring program, but it needs to be revitalized. So we're looking to do that. And we would love someone or someone's, it could be two people that co-chair like Bob and Rob or Chuck and Rob are co-chairing the boat shows. So please feel free to speak up and say if you would like to help with being a mentoring coordinator. And the other positions, very much committee positions. And anybody with a marketing expertise and background, please, please, please see me. All right, next. We have a lot going on. And that lot going on brought in 37 new members in the last 6 months. I think this is a record. Who is a new member listed here? I know we've got Holly. Yep. And Randy. Awesome. We have something for you. If you can grab those, Bob, it's in, yes, the white paper, not the blue. Thank you. We have just a little token of our appreciation for you. Excellent. Randy and Martha and Holly, let's everybody give them a hand. Thank you so much. Next, we have a lot of opportunities to represent CAPCA, and one of them is at the boat show. So there are 4-hour shifts, and Rob and Chuck are here if you have any questions about what's involved in it. And on your table, Rob, hold that up very high. And those of you who are on Zoom, you can just scan it right there with your phone, the QR codes to sign up for either the powerboat show or the sailboat show. And this is sitting in a booth and talking to anybody that comes up and ask about CAPCA. And you get free admission to the sailboat or powerboat show, and you can have your parking reimbursed in case you have to pay for parking that day. So please feel free to sign up for helping out. Anything else, guys, you want to say about that? All right. Okay. Programs. Next month, a month from today, is our March 23rd program about colonial Chesapeake maritime history, presented by a local author. He is also a musician, and I hear sea shanties might be in order for the evening, so that could be a lot of fun. So please come to that, and it will also be held in Zoom. And April 27th is our program that was rescheduled from January. So, we pushed it a week. We thought that was enough, and then that wasn't enough. So it will be held here at the Elks and also on Zoom. And we'll have the Coast Guard here to talk to us about regulations and procedures for inspected and uninspected passenger vessels. So very much looking forward to both of those programs. Programs are always free. They're always open to the public. So feel free to bring your friends, your spouses, whomever. Everyone is welcomed here. And you don't have to RSVP. And look how many people showed up. I thought we might have like 10 or 15. I'm so happy to see so many people. All right. Tour of My Tags. This is new. If you haven't seen this, it's been sitting on the website for a while. We sent a constant contact out about this a couple of days ago. There are only 20 spots. And as of this morning, I think I saw that 20 spots? Yes, 20 spots. And I think this morning I saw 8 were left, or maybe 7 or 8. So if you're interested in touring My Tags and seeing the simulator and hearing more about their program, join us. If you're a member, it's members only, on March 16th. We also have a class coming up that will be here at the Elks on Wednesday, March 11th. It's an evening class. It is open to non-members as well as members, and it's a winter refresher on navigation taught by Tate Westbrook, who is not able to be with us tonight. I had someone pull me aside at a spin sheet party over the weekend and said he had just spoken to their yacht club about a similar subject, and she was blown away about the stuff she didn't know. And she is an avid racer, does the Annapolis to Bermuda race every year. So he is teaching. If he can teach her something, I'm very interested in knowing what he's teaching in this class. So just know that this is a really awesome opportunity for very little bit of money. Okay, with that, we are to the 50-50 raffle. All right, how did we do, Greg? I don't take a door prize, by the way, ticket, but I do pay him for this. So I don't get to see, speaker usually. Jason, you get the pick. Four, 8, 9. Oh, Holly. Well done, new member Holly. Thank you, Jason. All right. Okay. Okay. Dave Sire just took that money to deposit. Okay. I'm watching you. Okay. All right. Okay. And all right. So now let me introduce our speaker. It is a little different than the bio that you see. Um, Jason is the Deputy Director of Project Development for the Maryland Transportation Authority. He has 15 years of highway design and roadway project management experience, specializing in alternative project delivery. He is a professional engineer licensed in the state of Maryland. Jason graduated from University of Illinois, Urbana-Champaign with a Bachelor of Science in Civil Engineering. And Jason, we are very excited to hear you speak on this topic because it has been on the minds of us for over 2 years now, or about 2 years, right? 2 years next month. So thank you very much. We look forward to hearing from you.
Well, yeah, thank you very much for having me. I'm really impressed by the turnout tonight. And yeah, thank you very much for having us at your event. Um, we'll talk a little bit about some of the design elements and some of the work that we've done over the past year and a half in design, almost 2 years since the collapse, to get where we are to say that we're actually progressing some of the critical path construction elements as we speak. And we're also joined by a member of Kiewit Company, who is part of the rebuild effort. He's going to talk about some of the marine equipment that we have out there in the Patapsco and in the Baltimore Harbor. Looking at the bridge design, we had talked about a year ago now. We had the governor was able to join us for an unveiling event of the type and nature of the bridge, which was this cable stayed design. So the cable stay essentially it differs from like a suspension bridge like the Bay Bridge, where instead of having a continuous suspension cable run from one end to the other, you have a series of discrete cable stays. So you can kind of see how you have sections of the bridge that are supported by those cables as you go from one end to the other. So as you have the towers that come out of the water, you have those cable stays that are attached to the towers, and then the stays themselves hold up the bridge deck. This is sort of the, if you guys are pilots and familiar with being on the water, this is sort of the modern uh, design of choice for spanning large scale channels or any sort of large span requirement of a bridge of this nature. So looking at the bridge typical section, the roadway is going to be essentially putting back what was lost with the collapse of the Key Bridge. The funding mechanism that we have the ability to access in order to receive federal funding to help support the rebuild requires us to build back the system as it was previously when the collapse occurred, but allows us to use modern standards. So the old bridge had 2 lanes in each direction. That's what we're putting back as a part of the project. But we are able to utilize current shoulders inside and outside in order to bring it up to a modern facility standard. Here, this is sort of looking at the main span section of the bridge. You can see we have 10-foot outside shoulders. Each of the lanes are a standard 12 feet wide. We have a 4-foot inside shoulder on either side for an overall out-to-out width of 78 feet with a 5-foot, what we call a maintenance walkway beyond the bridge barriers to allow us to go in and maintain the bridge periodically throughout its life. Each of those cable stays requires maintenance, requires access. So it's key for us to get behind there. We have 3 different 42-inch barriers, which are required for traffic safety. The median side or the inside will be a concrete barrier, like you'd see on any sort of conventional highway or highway bridge. And the outside is going to be a semi-open railway system where we have a lower portion that is concrete with a 2-strand metal barrier. And we'll get into our wind modeling a little later, but that open barrier was very key to getting a desirable wind model result when we tested our bridge in the wind tunnel. So looking at the bridge layout itself, the distance between the 2 towers and that constitutes the main span of the bridge is approximately 1,665 feet. The old bridge, the distance between the 2 towers there was approximately 1,200 feet. So we're several hundred feet away from the channel in both directions when compared to the previous bridge. And this bridge is a little unique in the way that it's very symmetrical in its backspan as well, with the overall length being approximately double the main channel width. We'll have a minimum vertical clearance of 230 feet above the navigation channel. And because the channel is 800 feet wide, the center of the bridge is actually 10 or 15 feet higher than that minimum vertical clearance. So as I alluded to before, with the cable stays and the cable strands, there's 144 of those, 72 on each tower, and then they're sort of distributed evenly so that there are, I believe, 18 sections going out towards the middle on each side, and each of those cables supports one of those sections of deck. The pylons themselves, the largest of the concrete elements, those will be over 600 feet in height when built. So the old Key Bridge at its highest point was about 360 feet. So this is substantially taller than the previous Key Bridge. And the Bay Bridge, for frame of reference, is about 400 feet at its highest point. So it's substantially taller than the Bay Bridge as well. Those are sort of oriented in that goalpost or tower-like design that you've seen in the previous renderings. The foundations with the cable stayed bridge are substantial. They have to resist a tremendous amount of force as they span such a wide distance. They have 6 total piers, 3 on each side. We're sort of looking at the southern side, and it's mirrored on the north side here. Each half of the bridge comes with a pylon that then goes into a tie-down pier and then transition to a more conventional bridge type at the transition pier. And the transition pier and tie-down pier sort of work together in order to withstand a lot of the uplift forces that are experienced on that side of the bridge. Each of these smaller foundations, and I say small in quotes, they're quite large. Each of the smaller foundations here on the transition and tie down are founded with 10 8-foot diameter steel pipe piles that are all in excess of 200 feet in length. If you've seen us handling any of our large piling in the harbor over the past few months, those are those elements. We have 10 in each of those foundations. And in the main bridge foundation, we have 45 of those large pipe piles. And so that's 10 plus 10 plus 45 is 65. So we have 130 in the bridge itself. But that's dwarfed by the number that is in the vessel protection. And we'll get into that a little bit later. So sort of looking at a cross section here of those pile foundations, and this is our main pylon. Has those 45 8-foot pipe piles in a 5x9 formation. And like it says here, they're over 200 feet into the long and embedded 60 to 70 feet or so into what we call the Patapsco geological layer. It's a very dense sand layer that supports the bridge. The Patapsco in some locations is 80 to 100 feet below the water surface. So there's a significant distance to go before we even get to that sound bearing layer, which is why the piles are so long. The footing that we have is approximately 100 feet by 176 feet. We like to compare everything to sports stadiums and courts and whatnot. So this is approximately 2 NBA regulation basketball courts, and the pile cap, it's the pile cap is actually above the water line and out of the splash zone, and that's in order to make it a more constructible element. That pile cap is approximately 20 feet thick. Each of the pile caps is 13,000 cubic yards of concrete, which are, it's an enormous amount of concrete that will get poured in 3 different lifts. And each of those lifts will take us approximately 36 hours to pour, with continual concrete delivery through those lifts where we're pouring 6 to 7 to 8 feet of concrete at a time. So you can see each foundation will have over 13 truckloads of concrete, 1,300 truckloads of concrete, again, placed in 3 layers. Go into the pier protection system, and this is looking at that main pylon again. The pylon is, the foundation itself was large, about 100 by 176. The vessel protection or pier protection system is almost twice again as large, or more than twice again as large, where it's 374 feet on the long axis and 214 feet on the short axis. I said that each of those main pylon foundations had 45 of those steel pipe piles. The pier protection system at the main foundations alone have 78. So they have half again, or almost twice as many pile as the foundation system that's holding up the entire bridge, and that's to withstand vessel impact in the event of any sort of future unfortunate events. We'll talk about some of our pre-construction activities, what we've been doing over the past a little over a year now. We've spent a substantial amount of time and effort collecting geotechnical borings, both on land and in the water. You may have, we went through a process early last year of collecting borings along the original bridge alignment. What that allowed us to discover was that we had some elements that were in the way of building the new bridge. And we've actually shifted the bridge 260 feet to the east, sort of away from Baltimore and towards the Chesapeake, in order to minimize any potential conflicts between buried materials in the river and where we're proposing to build a new bridge. So we did a geotechnical investigation on that first alignment, then we went back out and did new geotechnical borings in order to ensure that the new alignment was clear as well. And we got favorable results from both of those investigations. That wrapped up, I want to say September or October of last year, and was 6 to 8 months of geotechnical data collection. So unique to this type of structure and unique to very niche structures is we actually utilize the firm and our our progressive design builder, Kiewit, utilized a firm called RWDI. They're a very boutique engineering firm who specializes in niche modeling opportunities. A lot of what they do is in the wind arena. Because each cable-stayed bridge is a unique element, it's not an off-the-shelf design. You can't go to a design manual and say, well, based on the square footage of bridge deck, I know how this is going to interact. They have to create scale models of different elements of the bridge. And you can see this is a cross-section of the bridge deck that's fully loaded with traffic. And they test it under different load conditions, under different wind conditions, and different angles of attack of the wind in order to ensure you're not going to have any unexpected reactions once you get the bridge in service. You know, everybody's seen the Tacoma Narrows galloping. You don't want that, obviously. So in addition to this, where they're sort of testing low frequency oscillations, there's sort of a phenomenon where you get no reaction from the bridge at low speed. You get to a certain wind level where you actually get some level of reaction. Then you get higher than that, and the reaction goes away. And then, you know, once you get to tornado levels or hurricane levels, you get reaction come back in. So they're able to test different mitigation elements in order to make recommendations on how to most economically deal with those low level oscillations and ensure that you don't have any normal state issues when the bridge is in operation. So all that's to say is that they cut this bridge into multiple pieces. They run different wind models across it. They also have a full-scale version of the bridge, which I believe was 1/20th scale, and it's an enormous wind tunnel. Maybe it's 1 to 200. That sounds more manageable. And they build it on top of a turntable, and they're able to bring the wind to it from a number of different angles. And then once they've demonstrated that the bridge in its full build condition is suitable to take the wind loads, they start deconstructing it to represent the in construction phases of the bridge. So we have all of the different elements of building up from the water line up to the highest point, and as you build across to connect the two sides of the bridge. So it's really interesting. You know, if you guys ever find yourself building a bridge, I highly recommend going up to Canada to see it. They're outside of Toronto. They have multiple locations worldwide, but a lot of their North American operations. So we talked about the air. Now we have to talk about the water. Again, when you're working on a structure of this scale, none of the models, none of the conventional testing or analysis that's been done in a book is applicable to pile formations that are this large, that are of this scale, and that are in this type of geotechnical environment. So I talked about that Patapsco layer, which is our hard bearing layer, which is where we're driving the piles to. But on top of that is layered this. It's a lot of just, it's what the core takes out with dredge. And it is just a very soupy, messy layer that goes, 30 to 50 feet deep in some locations. So what we were able to partner with the Federal Highway Administration's Turner Fairbanks Research Center down in McLean, Virginia, to help us do scale modeling of the Patapsco and of some of the unique river geometry that we have at the Key Bridge location, in order to test the scour that we might expect to experience at the foundation locations. So they built several different scale models, and they ran it through this water table that they have, and are able to demonstrate what the effective diameter of these piles are, which we're able to utilize in our scour calculations in order to demonstrate that the bridge isn't going to lose any of that foundational material over time as the water moves around the pile formations. So ultimately, we made various conservative assumptions early in design in order to ensure that we'd be able to move forward and wouldn't have to backtrack. And this testing that Federal Highway did for us was able to confirm that those assumptions were correct, maybe a little conservative, but were suitable to move forward with. If you've been out on the water, you've noticed that we're taking apart most of the old bridge. So I talked about that shift of the alignment about 260 feet to the east. So the east would be like this side, to the right in that picture. We've left a couple sections of bridge with that shift. It sort of reversed what was in conflict from the existing bridge to the new bridge. When we stopped building on alignment, this section of bridge was no longer in conflict with the proposed bridge. So we do plan to take it down. Eventually, it was just no longer the most important element of the bridge to remove. So we started that demolition in July, and we're able to wrap that in early February. And we've completely removed the bridge on either side. So now I'm going to have John Kelly from Kiewit. He's helping lead some of the marine construction activities. And he's going to talk to you about some of the work that he's doing, as well as some of the equipment that's out there in the Patapsco.
Thank you, Jason. Good evening. I'm John Kelly with Kiewit, the design builder of the Key Bridge. I'm a project manager working on the marine scope. So one of the first scopes we started with out on the water was the test pile program, which is essentially an effort to validate the design process throughout the design process for the bridge. So the test pile is essentially driving foundation piles in the pylon footing footprint with at each location, which are the pylon piers, receiving 6 piles, 4 of which will remain as permanent pilings for the pylons, 2 of which are sacrificial for testing purposes. So you see in that bottom left photo there, you have what we call the load test frame. And what the frame does is it's a large steel girder structure that spans the 4 piles that will remain that are referred to as reaction piles, and lands over top of a pile in the center, a test pile, to do an axial load test or testing the loads up and down throughout that pile. So the load test equipment is made up of a jacking system. You can see in the bottom right picture there, about 9 jacks around the diameter of the pile that ultimately push up against the frame and down into that reaction pile, or into that test pile that allows us to test the loading that foundation could ultimately take in the future. So at each location for the pylon piles, we completed the load tests late last year and early this year. And at each location is tested with 1,100 kips, which is 1.1 million pounds pushed into those pilings themselves. So each pile, again, as Jason referenced, are 8-foot diameter by 200 feet long. And we'll go through some of the equipment that allows us to install these foundations. So at each location, we carry with us a flotilla, which is made up of a crane barge and a handful of deck barges that go and have the ancillary and support equipment, which allows us to complete the construction. So in getting to each piece, the Weeks 533 is the workhorse of the foundation pile installation. It's a 500-ton derrick crane on a 300-foot by 100-foot barge. The crane is a Clyde 52, so the roller ring is 52 feet in diameter. This crane was made in the 60s and has gone through a handful of different contractors, but been with Weeks Marine and Kiewit for about 25 years. and has a 250-foot crane boom that allows us to install these long 200-foot piles. Yeah, so you see the this is looking up the boom down to us impacting a pile, and we'll get into more of the details of that operation shortly. So another crane barge we have on site is the Weeks 577. It's a smaller crane. It's got a 28-foot diameter ring, a much smaller barge used for smaller diameter piling, false work installation, and support hook work out on the river. This crane has been there throughout the load test after the piles are installed, installing the gauges and the jacks and the smaller parts and pieces. It is a smaller crane. It has about 150 tons capacity, so still a fair amount of capacity for a floating derrick, but a little bit on a smaller scale than the 533. So in order to install the piles, which range from 205 to 215 foot long with a 250-foot boom, we actually aren't allowed to trip and raise the pile off of a barge deck without losing some of the pile's toe into the water line in order to give us the headroom. So what we do is we fabricated a tripping frame. You can see there on the barge in the center, which basically just has a large seesaw effectively that allows us to take the pile off of the supply barge on the right side, transload it into the tripping frame, and then upend it, and that the toe of that pile then enters the water, and basically it ends up right above mud line, which allows us to go swing it into our false work to install the pile itself. We use vibratory hammers to install the pilings for their initial set, I'll call it. This is a common practice in marine construction, but on a bit larger scale for the relatively large 8-foot diameter pilings. Basically, a vibratory hammer essentially uses a bunch of uses rotation to cause a vibrating effect to seat the steel pipe into the river bottom. So while this doesn't create your final capacity, it allows you to take the pile as it's resting in mudline under self weight and seat it into its position, and allows for better quality of construction. Basically allows you to hold your location of that piling as you go. Yeah, so the next step is impacting, as you say, the pounding, which gets it to its final location and gives it its final capacity. So we have the impact hammer, which in this case is it's called a Menk 800, which refers to an 800 kilojoule hammer. The hammers are rated essentially by its maximum energy. So in imperial units, it's more referred to as kip feet, 1,000 pounds times feet. It's a relatively simple calculation, physics or statics, where if you have a 1,000-pound ram on a hammer, it can rise 5 feet. It's 5,000 kip feet. So this is 800 kilojoules. I'm not too slick with the metric conversion, so bear with me, but that's what we have. So it has a sleeve that sits over the top of the pile to get a good seat on the pile, and then impacts the hammer down in location, which we use a set of metrics based on the amount of blows of impacting per foot of advancement, which indicates you have the proper capacity on that pile. So we also use, during our impacting, as an environmental mitigation, what's called a bubble curtain, which is essentially a shroud to protect the marine wildlife from the noise of impacting. So this is what we have as a barge as a setup. Is relatively simple with a technical application. It's a series of air compressors fed into a manifold that distribute air into what ultimately results in a bubble curtain. Pretty literal translation, but we have a column of rings that surround the pile itself that have perforations where the air is introduced. It creates a significant amount of bubbles and turbulence, which is a noise shroud for marine wildlife. We try to keep the in-water decibels to round numbers below 200 decibels to protect the fish. This is a relatively common practice in bridge construction, not all marine construction, but mitigation strategies like the bubble curtain allow the schedule to accelerate and work through the full calendar year through fish spawning seasons and fish migratory patterns. So we have a variety of marine support equipment out there. This is this tugboat we have here is a 3,000 horsepower tug, the High Roller, which is with Hayes Marine. We use a variety of tugs either on a spot hire or in the High Roller's case a dedicated boat basis, which brings our barges back and forth from moorings to the site, rearranges them around our barges as we need throughout the shifts and over time. So we talked about using the vibratory hammer to seat the pile into its location. We also use a series of false work to guide the pile as we go. So we have a deck barge used with a two-tiered, what we call a template or a false work system, which allows us to place the pile into the template as we take it off the barge and into location. So essentially, we pick up the pile, swing it over, put it into its false work, and let the pile rest under its self weight before we move to the next step and vibrate it in. So it's a relatively common practice in marine construction, but on a larger scale, you can see you probably got a good 25-foot stairwell there to get to the upper level, and these two tiers really help us again from a quality perspective, allow to get the pile plumb so we can drive it straight and keep it in location, and to provide a clean path for the loading ultimately from the pylon down. So again, this is more of a front elevation or rear elevation view. The piles themselves typically have about 80 foot of embedment on self weight alone. This takes it down through some of those as Jason was saying, the softer layers, goose crap essentially there at the top, and as the pile rests down, it seats itself into location under its own weight. The Weeks 575 barge is another floating derrick we have there. This is a relatively mid-sized rig, I'd say. It's got a 28-foot diameter ring on the crane. Again, you get up to about 200 tons of capacity. We're using this for the trestle construction, which is a temporary false work structure that it will be there through a significant amount of the bridge construction to facilitate equipment, supplies, and labor getting out to the site. A little bit more on the trestle here. So as you can see, this is looking on the bottom left would be the south side of the bridge. A trestle structure is essentially driven pile with it's essentially a temporary overpass of steel fabricated material and wooden mat deck that allows us to set cranes, concrete trucks, different supplies, and allows our people to get back and forth out to the site. So this will travel out along the approach side on the south side out to the back span of the bridge out to the piers, and allows us to really continue and facilitate construction. And as you see it from the water, as you see it from the water as you're navigating the river, this will be something in place that blocks that shore out from the south side, almost out to the navigation channel here from the south and the north, starting early this year through late summer, early fall. Yeah, sure.
So I just want to hammer home that point because this is of a lot of importance to our mariners, to anybody who's going to be operating a vessel on the water. This is a temporary bridge that's going to go from either side of, say, Dundalk or the Glen Burnie side out to those main pylon locations. So we're going to have what is essentially a slightly above waterline bridge that is out there for the next 5 years. Both sides at the same time. So, and I just want to stress that it's all in servicing this construction. The pylon is the critical path of this job. Until we build down and up on the pylon, we've made no progress on the bridge. So in order to be able to march those 1,300 concrete trucks out to the pour, we have to have that trestle in place. It would take us longer and would cost us more if we didn't have it. So I just want to be clear that we are restricting the vessel access through the project site and through the old bridge location to the area to the shipping channel, to the federal channel, and then the area adjacent to the channel. And that's what this visual is showing. So within the construction zone itself, I believe that's 1,000 feet on either side of the bridge. We have a no entry zone, which will encompass, and this is already in place. So we do have some vessels that currently go through the no entry zone, but it is marked with buoys and will become impassable over the next 6 to 9 months. Beyond that, we have a 6-knot no wake zone, which I believe is about 500 feet outside of that 1,000-foot no entry zone. So I want to stop here just because we may have, or do we want to take questions or just keep going? All right. Yeah. And I also want to just, John was showing you the pile, the elements that hold the pile as they drive them into the ground. He was talking about that 800 kilojoule hammer with the 8-foot pile that's 200 feet long. They have 3 inches of tolerance one way or the other. So that's why everything has to be almost perfect, because in order to ensure that we're able to move on to the next step of construction without delay, we're prefabricating elements of those foundations off site, and there's only so much play they have one way or the other. So really it's a lot of effort at a large scale that ultimately ends up as a game of inches. I think a lot of folks saw the news like this last year with an updated cost range and open to traffic date. We have the updated cost range of 4.3 to 5.2 billion, with an estimated open to traffic of late 2030. So we had early estimates that were at a lower range. Really, we developed those extremely early in the process before we had any sort of formalized site knowledge of the geology, of what would be possible and what wouldn't, the scale of this, and was done as a programming mechanism in order to set up the federal funding eligibility while we were doing the recovery effort in the immediate aftermath of the bridge collapse. So within the past 14 months, it's probably more like 16, we've reached a 70% design completion on comparable bridge projects. That's a process that takes 6 to 7 years, not to mention the probably 10 years they spent in planning before they got to the design part that took them 6 to 7 years. So we've been able to take in all the data that we've been able to collect, which has helped us refine our estimates. And ultimately, it has yielded a price range and a construction duration that's higher and longer than we anticipated. So again, those key cost drivers, I don't think that we did not contemplate this type of pier protection being required, which was necessitated by the geology that we see at the site, that goose poop that they talk, just that layer that is at the base of the Patapsco, and on top of that strong layer, provides no structural contribution to anything, and made more conventional construction techniques either completely non-constructible or impractical. The main span of the bridge, again, is longer than originally anticipated, and we have seen continued escalation in the construction sector as we go out on projects of this scale, which was not contemplated at the time that we put together that initial estimate. So again, with what we're putting together, we're meeting modern design standards, federal requirements, and best practices. So moving forward, we can go back and look at some of the pictures that John showed. Some of those show the first pilings that are going to be part of the actual pylon foundations and those pier protection element foundations. John, do you have a current count for how many pile we've installed? Yeah. So we're at 20 of 400. So we're making slow progress, but part of that slow progress was that test pile program. Because it was installation and then testing, that does take a bit of time. In the past month, we're getting up to speed, and we're going to have a second setup that is going to be driving the northern pile concurrent with the southern pylon location as well. Yes. Oh. Yeah, the question was, are the pier protection pilings also those 8-foot, 200+ foot long pipe piles? And the answer to that question is yes. And, just from a broad perspective, there's about 400 of those 8-foot diameter, 200-foot long pipe piles. About a third of them are in the bridge foundations. 2/3 of them are in that pier protection system. We have workers around the world who are contributing to this project, both on site, doing the installation, as well as working diligently to progress the design and get us to full-blown construction as quickly as possible. We continue to work with Federal Highway and the U.S. government, as well as our design partner, Kiewit. We are working diligently both to control and monitor the project costs directly, but also to continue litigation with the ship owner that is the entity that's responsible for the collapse, and recouping as much as possible from them as part of that settlement. And that element helps offset some of the federal government's investment in the bridge itself. So sort of looking at where we are and what we've been doing, we started this process in summer 2024. We're in winter 2026. We've started that trestle construction, the pylon construction. Those are sort of very repetitive activities that have to get done before we start building up. But once we start building up, we'll see foundation work start, and then we're going to start seeing ourselves go vertical. And again, a lot of this is repetitive and has to be done multiple times because we've got this long bridge span across the water. But as we get further into construction, we'll get more economy and get smarter about how we build, and hopefully we gain time as we go. So really, we're working on that pylon construction, starting our build effort in earnest with an agreement this summer with Kiewit, working on the approach span bridges, and then start hanging those cable stayed spans out in 2028. Like right on the edge of the clicker working, so I apologize. We've done a tremendous amount of engagement. We have a crew who helps spearhead our engagement, and I just come here and talk. They do all the work of prepping and getting everything in order and making sure I show up on time. So we've had over 100 pop-up events, over 50 speaking engagements. We we encourage you to take our survey on the website, tell us what we're doing well, what we could improve on. We count our connections at those pop-up events and speaking engagements. We have a wide array of email subscribers, and we'll have our Stay Connected slide in a second that you guys are, we encourage everybody to sign up and get periodic updates about the project. We have over 29,000 subscribers on Facebook. So really, we're putting, I see the information that our team is putting out there, and they do a great job. We have pictures and video like what we showed you tonight. We get that on at least monthly basis. So we always have great pictures of what's going on. So if you want to stay involved, that's definitely the best opportunity to do so. So again, with that, we have these Bridging the Facts series, which have information and stats about the bridge. We have weekly catch-up emails. We have a monthly newsletter about everything that's going on, the people working on the project, and how to stay abreast of the work. So again, please join us. Visit keybridgerebuild.com. Sign up for our emails, join the Facebook group, and follow us. Just sort of talking globally, at Kiewit, we're in what's called a progressive design build model. What that essentially means is that the Kiewit companies is both the entity doing the design, they're the designer of record for the bridge, but they're also, assuming we're able to agree to a price this spring, they'll be the firm that constructs the bridge as well. So they're going through a significant subcontractor solicitation and quoting process that's sort of in its late stages now, but they have a lot of quoting opportunities throughout the life of the project as well. So we encourage you to go on, if you search Kiewit, KeyBridge, if you're a small business, if you have services that you can help provide them. They have these bidding access forms that you can fill out, talk about that you can select your service type. Like if you're a commercial captain, you can give them that information, and everything that's flagged with either like tugboats or crew boats or something like that. They would ping you directly once they have a solicitation that's available for that type of service. And we can also get the leadership here connected with Kiewit. They've offered to do a follow-up if you guys wanted to see some of these things more closely in Baltimore as well. So we can follow up with that, Cheryl. Yeah. All right. I think that's our last slide. Do we want to open to questions?
Just curious, before this final decision was made on the bridge, did they do an analysis of doing a tunnel instead of a bridge? And if so, what was the cost differential?
So because of the funding mechanism that we have, it's called the Emergency Relief Program. So anytime there's a disaster event that happens that results in a complete loss like we experienced, you're eligible to receive funding to replace what was lost, and it has to be in the nature in which the previous system was. So because of that funding mechanism, we weren't able to utilize that funding towards a tunnel. And sort of beyond that, because we have the Harbor Tunnel and Fort McHenry in Baltimore, other than the Beltway itself, there's no interstate system that provides unrestricted access to the port, both from a width and height perspective, as well as hazardous material handlers who do go in and out of the port facilities as well. So in order to meet the needs of the port and the businesses surrounding the port, and just to go back to when the bridge was originally constructed, it was contemplated as a tunnel in the late 60s and early 70s, but due to these similar restrictions, it was then transitioned to a bridge instead of a tunnel.
Is the maintenance cost for a bridge similar to that of a tunnel? Do you know?
I don't know that off the top of my head, but I do know that our most substantial maintenance investments on our system are in the tunnel.
Great talk, Jason. John, thank you very much. Two-part question, hopefully not too loaded. Main span construction, is it proposed to be precast or cast in place traveler system? And I ask that because will that require any channel closures?
So we are not planning on doing any lifting from the channel with pre-assembled deck sections. We are planning to stick build the structure and use a balanced cantilever approach. Let me get a good picture that I can talk to from this. So, and again, a reason why that trestle is so important. Really, the bridge, once you get to a high enough location where you can start hanging the deck, you build it from the pylon out in both directions on both sides of the river at the same time. So you could pre-assemble deck sections and lift them up, but that requires you to be below the bridge. We did an analysis and found that it was probably about the same duration either way. And stick building it in pieces, bolting up sections of girders, and then laying in the deck on top of it, sort of iteratively as you go away from the pylons, we believe is the less impactful option for ship traffic. And we're working with the Coast Guard and the Army Corps and the captain of the port in order to figure out what that scheme is exactly going to look like. There's going to be a dilemma zone where we can't have ship traffic below an unbolted section of girder. So there's a time when we're doing that lift operation where it's not safe to have vessel traffic underneath it. That outage in any given location might be 6 to 8 hours, but would be planned ahead of time as well. So there are a lot of those activities, and we try to do as many of them as we can concurrently. But especially once we get close to that closure, everything that we're doing is within the channel. And that's going to be the point at which we have the most impact to marine traffic. But again, we're able to limit that to 1 day as opposed to like a prolonged closure period, and work with the port and with the captain of the port and with the Coast Guard in order to determine when that's the least impactful.
Okay. Yeah, I didn't realize it was composite steel and concrete. Second question, which probably a lot of folks in this room will want to ask. We have a lot of captains for hire. From my background, as I mentioned earlier, I'm very familiar. You're going to have crew boats, environmental boats, safety boats, what have you, running around. The captains that you'll be hiring, will the PLA union agreement be required?
That is a question for Kiewit. And I don't know if John's the right person to answer that question either. John, if you are.
Okay. Yeah, no, I didn't mean to put you on the spot, but
Yeah.
I'm sure a lot in this group are going to want to know, how that's going to apply for hourly or whatever captains that you may require. Yeah. Thank you.
Yeah, please come find me. I'll give you my contact information. Fortunately, I can't answer that tonight, but I can get you in contact with the person who can.
So I have two questions. One is, earlier in the presentation, you mentioned that the bridge had to be moved east because of something way down in there that was
Yes.
preventing dropping the piles. What is that something?
It may be remnants from the original bridge construction that was there, that was structural elements that were used to support the bridge that were cut at the mud line and left there. It may be part of the bridge that collapsed. We're not entirely sure, but we're not going to spend the time to go figure out exactly what it is, because we believe it's 30 to 50 feet into that mud. So to go find it and take it out would be a tremendous effort.
Second question. At the end of June, the Sail 250 MD event is happening. We've got about a dozen tall ships, 4 Navy gray hulls, many schooners, etc., coming in to the port. Any restrictions on that other than the 6 mile an hour no wake zone through the channel?
Well, and I mean, I believe, and I could be wrong, I would check your local notice to mariners, but the channel itself is not restricted to speed. The 6 mile per hour restriction is the area directly adjacent to the work zone, but outside of the channel. So we, other than us passing ships or passing barges or moving the tug from one side of the channel to the other, there should be unrestricted access to and from Baltimore until we get into that deck erection sequence. Thank you.
Two questions. One is you mentioned the cost being about $5 billion. Realistically, what percentage of those costs do you expect to recover from the insurance companies associated with the freighter that caused the original damage?
I don't think I'm allowed to speak on ongoing litigation, and I also do not know. So I'll say both of those things at the same time.
Okay. And then the second question is on the protection barriers. Freighters are getting larger. This bridge is obviously built to withstand decades of use. The studies that you do, if there were a similar kind of situation with the larger ships as well as potentially more speed, how does that all work out? Are these protection barriers still going to be available to work as you expect, even with the future larger ships that will be coming down the pike?
So as part of the analysis that led us to the design that we have, they do a vessel analysis and an analysis of all the vessel or the traffic coming to and out of the port. So they're able to take that information, see what we have now, and then they grow it for what they believe the future vessel composition is going to be. So they're able to make some assumptions about that growth in vessel size. As far as the speed of operation, because we're so close to the port and the port facilities, and given some of the geometry of the harbor itself, they're not able to get up to full speed in most cases. By the time they reach the bridge, they're kind of limited to. I think that for ships of size coming in, that was max 10 or 11 knots. But most are traveling at like 6 or 7, right above their sort of minimum operating speed as they sort of slow down to get to the port facility. So we wouldn't expect a huge increase in ship speed, but that's definitely one of those are the two primary data points, as well as some ship geometry elements and determining how large those pier protection need to be.
Thanks.
Yeah.
It's along that same line, because the center span towers are further apart. Do you have an idea of what the water depth would be at that tower center span level to which a ship would run aground long before it would hit that barrier?
Well, so that's sort of the double-edged sword of that very loose material. At those locations, it's probably 20 to 30 feet deep. But with how loose that material is, it provides almost no resistance capacity to a ship in getting to the bridge. So the reason why, you know, the largest vessels would travel in the channel. So you'd think and the largest protection measures are around the channel, but in the modeling and in the potential trajectories, that's why we have the pier protections on the further away, is because if you had an errant vessel that was to lose steering on a unique path, they would be able to get to those rear transition and tie down piers, which are some almost 2,000 feet away from the channel center line. And that material just provides no resistance. We'd love it to.
Online question. Are the piles evacuated before being filled with concrete after being driven into place?
Sorry?
The pilings, are they evacuated of water and then filled with concrete after being driven into place?
Yeah, so in order to form the structural competency coming out of the pile, yes, they're going to go muck out the pile. They're going to install rebar cages into the pile, and then they'll put a concrete plug coming out to form that consistent structural connection to the foundation.
If I remember from your slide, it looks like the vertical clearance is going to be 230 feet,
Yes.
but the vertical clearance of the Chesapeake Bay Bridge is like 185 feet. Why'd you go 50 feet higher?
So we also own the Bay Bridge. So we had been working through our NEPA analysis, and we're wrapping up the tier 2 study for NEPA and the Bay Bridge. So all that's to say is that when the bridge collapsed, we were in the process of determining a navigational recommendation with the Coast Guard of what the channel should be up to the harbor. So the 230 feet is a recommendation from the Coast Guard in order to accommodate future growth at Baltimore Harbor, and that's part of commerce and national security decisions that the federal government makes. So they recommend to us the elevation of the bridge. I would imagine it's going to be the same at Bay Bridge as part of their recommendation, but we await that recommendation as well.
So just the pilings go in, 400 pilings, not in one area, but a lot of pilings.
Mhm.
What goes on top of the piling? That's the concrete bed on top of the pilings. What supports that chunk of concrete that's sitting on the pilings? How does that work?
We've spent the better part of the last half year figuring out exactly how we're going to handle that problem. So, some of the pile caps or are actually above the water line, as I said. So they sit on collars that get clamped onto the piles themselves and then grouted into place. And then we were manufacturing precast planks to be like the base of our false work, so that we can do that muck out operation within the pile, remove all the water and dredge material from inside the pile, drop our rebar cages into the pile, which will have already dropped that foundation layer, that foundation slab, so that at some point, once we get to the top, we'll have poured all of the concrete into those piles. We'll have rebar coming out of the piles. They'll form edges around that flat top or base of the foundation itself, and then they'll do that first pour, which creates the connection between the foundation itself and then that first layer of concrete. So we're manufacturing that base layer of those precast decks or floor sections that have that 3-inch tolerance, and then they're going to have formwork that creates the other four edges of each of those foundations. Yeah.
Thank you.
Throughout this process, do you embed sensors in the pile at different column heights so you can see over time how things are aging underwater?
So it's easier to assume some level of sacrificial thickness in the pile, and also use coating material in order to minimize the amount of material you lose over time. We are planning to install structural health monitoring elements throughout the superstructure portion of the bridge, in order to see how things are moving and expanding and contracting with temperature and time. But with the foundation itself, it, it's easier to just to know that you still have a suitable foundation.
What's the lighting strategy for the bridge?
So I don't have any of our pretty nighttime lighting pictures, unfortunately, not in this slide deck. But we've planned for cable lighting and uplighting on the bridge itself, as well as lighting on the approach piers. Part of that is aesthetic considerations. Part of that is lighting for the Coast Guard's purposes as well. We'll also have navigational lighting and air traffic and aviation lighting. Sorry. In addition to aesthetic lighting and roadway lighting on the bridge itself.
Okay, and this one is for Jason, I think. But you talked about the machinery making noise up to 200 decibels, and that you were using those bubblers to kind of like diffuse it a bit. What's usually the impact on the animals, like the fish, of that kind of noise? Because 200 decibels is incredible, like in terms of, it's really noisy. I don't think any of us could withstand much time. I'm sure all your employees are wearing like sound protection in their ears at all times of the day. So what's the usual impact on the animals around?
John, can I answer that one? All right, thank you. So I would say that, or the thing to note with the bubble curtain, that's why we use the bubble curtain, like 200 decibels on fish within close proximity will result in the death of the fish. That's why we're using the bubble curtain. What we're seeing is it's able to reduce the sound levels by 25 to 30 decibels and bring it down to 170-ish, which is still extremely loud, but that's below the threshold that would result in fish kills. And decibels are on a logarithmic scale. So, 20 to 30 of 200 doesn't sound like a lot, but it's actually reducing it in half every time you go 10 decibels. So you're almost dividing it by, what is that, half by half by half. So you're at like 15% of the sound at 200 as a result of the bubble curtain. Still loud, and fish kills are a reality, but they are something that we are looking to minimize to the extent that we can through the implementation of the bubble curtain.
Okay. I think that is going to be a wrap because we're at time. I want to have everyone give him a hand, and John as well. And we do have a small gift for both of you. I need to say this so the Zoom people can.
Is it valued at less than $20?
Actually, this is.
Oh, wonderful.
Because I know you work for them.
And as a government agency,
right.
Yeah, I can definitely take it.
I think with shipping, that was like $22.
Okay. Well, I don't think the shipping counts.
Okay, good. All right. But thank you very much. Okay.
Thank you very much for having us. And I'll say this group asked some fantastic questions, and your level of engagement was pretty impressive. So I thank you. It's good to do it when it's a well-attended present or meeting and with an engaged group. So thank you very much.
You're welcome. And now it's time, Will, if you can go to the next slide. You might have to skip a ways. I can put this down here. It's time for the door prize. All right. I never take a door prize. Okay. 50-50. Yes. So you guys got some of my money for that. But all right. I'm looking. Oops. 2. Okay. The last 3 numbers are 219. 219. Who got it? Will. All right. And such a reward for doing the AV tonight. It's kind of complicated. So the gift, the door prize, is, go to the next one, $50 gift certificate to Bacon's. I think Rob Doolittle got this last year, didn't you? So please, if you guys go to Bacon's, please walk in, ask for Stevie. You can't miss him, right? He's, really, really tall. Ask for Stevie. Say that Kapka appreciates it. And if you really wanted that door prize for yourself, please come back in 2 months because it's going to be our door prize in April as well. He gave us 2. So, all right. Okay. All right. So last slide is, these are the upcoming events in chronological order. I do want to thank Dave Oler, who couldn't be here tonight. He is online. He is the one that has been communicating with Jason and team to get everyone here tonight. So I did want to thank him for his participation in all of that and all of his efforts. I think, Jason, he started talking to you guys last summer, I think. So it's really lovely to have this event on and this topic that we all care so much about. The other thing I wanted to mention is the program committee does work very hard. So Chuck, who you've seen walking around, Bob, Hillary, who tried to get back here but is stuck on a plane in, couldn't get home from the BVI where she's been teaching as an instructor for 2 weeks. I know we feel really sorry for her. I don't know if she's online or not. And then Will, who is doing the AV in addition to Hillary. So the two of them share that responsibility. And all of this is a lot of work, and I hope you all appreciate it. And it's just great to have great speakers like tonight and these topics and have all of you turn out the way you did. We had 42 people online. So, so double the size of this room. But thank you so much for being in person, and we look forward to seeing you at these upcoming events. All right.